Today, we're going to talk about one of the most powerful tools out there for figuring out what's really happening inside modern software, distributed tracing. But to get started, let's jump right into a situation that, well, it might feel a little too real for some of you.
So, picture this. It's a Monday morning. The alerts are firing and customer complaints are pouring in. Your checkout page, the most important page on your site, is taking a full 8 seconds to load. With every tick of the clock, you're losing money. You know something is broken, but where do you even start looking?
And this is how the day just spirals out of control. 10 a.m., the problem hits. By 10:30, the whole team is in a war room. But for the next 3 agonizing hours, they're completely stuck, just manually digging through logs, redeploying code, basically guessing. It's not until 2 p.m., 4 hours later, that they finally find it.
So, what was the price tag on that 4-hour investigation? A cool $45,000. Just gone. That's the real cost of debugging in the dark, while frustrated customers just give up and leave.
Okay, so let's break down why this is so painfully difficult. This is what we call debugging in the dark. It's the old-school way of trying to find problems in these super complex, modern systems.
At the heart of it all is this. Our apps are built with microservices. And from the outside, the whole thing is a black box. You see a request go in, 8 seconds later, it comes out. But what happened in between? You have no idea. Your only clues are the logs from each service, but they're like disconnected stories. Each one tells you what it did, but not how it connects to the bigger picture.
And that's really the problem with only having logs. There's no single ID to follow one customer's journey from beginning to end. You can't see how long each step took. And trying to manually line up timestamps from a dozen different services, it's an absolute nightmare. It's slow, and you're going to make mistakes.
But what if you could have a tool that gave you X-ray vision? Something that let you see right inside that black box? Well, this is where distributed tracing comes in. And trust me, it completely changes the game.
Let's think about this like a detective story. Without tracing, you're basically trying to solve a crime with zero visual evidence. All you have are a bunch of scattered, confusing witness statements.
So the detective, that's you, goes and interviews each service. The API says, yep, I processed a checkout. The payment service says, sure, I charged the card. They all tell you they're part of the story, but nobody saw the whole thing. Nobody can tell you where it all went wrong. But then you bring in tracing, and everything changes. Suddenly, it's like you have perfect, crystal clear security camera footage of the entire event, from the very beginning to the very end. And this table? This is that security footage. Every single step is recorded with a precise timestamp and exactly how long it took. There's no guessing anymore. You can see the culprit, plain as day. The warehouse API call, taking a whopping 7.6 seconds. Case closed.
Okay, so this seems a little bit like magic, right? How does this security camera actually work? Let's quickly pull back the curtain and look at the core ideas that make it all possible. First thing you need to know about is the trace. You can think of a trace as the entire case file for one single request. It's the complete story from A to Z of one user's checkout experience as it travels through your entire system.
Now, inside that case file, inside that trace, you have spans. A span is just a single piece of evidence. It's one specific step, like a call to the database or a request to the payment service. And each span has its own timing data, building up the complete picture. So here's the secret sauce that connects it all. When a request first hits your system, it gets a unique trace ID. Think of it like a tracking number for a package. That ID is then automatically passed along to every single service that request touches. It's like a baton in a relay race. And that's what allows the system to stitch all those individual spans together into one single, easy-to-read story. So what does this actually mean in the real world? What's the bottom line impact? Let's go back to our disaster scenario one last time and see the difference this makes.
I mean, just look at this. This is the payoff, right here. Without tracing, 4 hours of pure chaos to find the problem. With tracing, 30 seconds. We're not talking about a small improvement. This is a totally different way of working. It's night and day. And here's the final scorecard. Your detection time goes from hours to basically instant. Your debugging time gets slashed from 3 hours down to less than a minute. And the impact? You completely eliminate those horrible, stressful 4-hour fire drills. They just stop happening.
So if you remember only one thing from all of this, let it be this. Distributed tracing takes the painful manual guesswork out of finding problems in complex systems.
It turns debugging from an art into a fast, visual, and precise science. And that really leaves us with one final thought. I want you to think about the systems you work on every single day. What are those weird, nagging performance problems you've just kind of learned to live with? What are the mysteries you could finally solve if you knew you could find the answer in 30 seconds?